Lesson 113 is about a completely new topic, so pay attention, take good notes. It is about what we call logarithms. First, what are logarithms? They are a different way of thinking about exponents. So we are going to be dealing with exponents in a little bit of a different way when we see logarithms. Here's what I mean by that. If I have 2 to the 4th power, that is my exponential. What that means is 2 times 2 times 2 times 2. This number right here tells me what number to multiply, and this number right here tells me how many times to multiply it. And it would equal 2 times 2 times 2 times 2 would equal 16. So 2 to the 4th equals 16. Well, here's what a logarithm says. A logarithm says, what if I didn't know this exponent right here? What if I had 2 to the x equals 16? What power of 2 equals 16? That is what a logarithm is asking. 2 to what power equals 16? The way I would write that is log with a base of 2 of 16 equals a power. Logarithms equal power. So look how this is related. 2 is my base, x is my exponent on that side, and 16 is my answer right here. 2 to the x power equals 16. This is what we call logarithmic notation. So here's what I mean by that. Log base A, well, we'll say base B. Log base B of A equals x. Here's what that means. Here's how you write it in exponential. B is your base. B to the power of x equals A. So logarithmic notation is just a way of writing it so that the exponent is your answer. B to the x power equals A. Log base B of A equals x. This is a logarithm. Here's the question it's asking. B to what power x equals A. B base to what power equals A, and it moves in a circle. Base to what power equals A. Here's some examples. Log base 2 of 4. 2 to what power equals 4? Well, the answer would be 2. Log base 3 of 27. 3 to what power equals 27? 3 cubed equals 27. Log base 10 of 100. 10 to what power equals 100? Well, the answer would be 2. Log base 9 of 81. 9 to what power equals 81? 2. They're not always going to be 2, but those are just easy ones to see. So logarithm, your answer is an exponent. So answer is an exponent. If you remember that, and you remember the question, b to what power x equals a. If you remember that, logarithms are very easy. Now there are two special kinds of logarithms that we see. They're called the common log and the natural log. The common log is actually this one right here. Common log has a base 10. So that would be 10 to a power. And we've seen that that's a special number anyway. We do all sorts of things with base 10. The common log, if you have base 10, you don't even have to write a base. This is what's on your calculator. Log, so say log of 105. Look on your calculator. If I want to do log of 105, I go right here. It says log right here. If you see log without a base underneath it, if it's just blank, that means base 10. So let's try log of 105. You should get 2.02. Here's what that means. What this means if I write it as an exponent is 10, that's my base, to the 2.02 power equals 105. Well, let's see if that's right. 10 to the 2.02 power equals 105. 10 to the 2.02 power equals really close to 105. We rounded up here, so that's close enough. 105. So the common log is a log with base 10, and it's on your calculator. These logs up here are not on your calculator. These are. Natural log is another one. Natural log has a base of e, the number e. Now we haven't really dealt with e, but e is a number kind of like pi. It's approximately 2.7182818285, and it keeps going forever, just like pi does. We use e a lot next year in exponential functions, but for now, the natural log has a base of e. When we have a base e, log base e, we write that as ln of a number. So log base e is going to be ln. So if I do ln of 105, look on your calculator for the ln button. You have one. Should be right here, right under log. ln of 105 should be 4.65. And what that's saying is e to the 4.65 power equals 105. Well, let's see if that's true. The way you find your E button is not one of your alphabet letters. It's right here above ln. You do second ln to get e to the power, and 4.65, and it equals 104.58. Again, close enough because we rounded. So this common log and natural log are what we're going to be doing a lot with right now until later in the year. This is your introduction to logarithms. Now let's do a few examples using the common log and natural log. An anti-logarithm problem is a type of problem where we will be solving for not the exponent, but the answer. Here's what I mean by that. If I have log of x equals 2, well, my exponent isn't what's missing. It's this answer right here. So what I do to solve these problems is I rewrite it as an exponential equation. I take my base. Now, there's no base written here, so that would be 10. 10 would be my base. 10 to my power of 2, remember the answer is the exponent, equals what I'm missing, my x. So 10 to the power of 2 equals x. Well, then obviously x would have to be 100. So let's do this one right here. Log of x equals 4.316. Again, my exponent isn't what's missing, so I rewrite it. 10, because there's no base right here, to the power of 4.316, go around in a circle, equals x. You can just do that in your calculator. 10, oh, here's the quick way to do it. Right above log is 10 to the x. You can do second log, and it'll go ahead and raise 10 to a power. So 10 to the power of 4.316, oh, there was no parentheses. 4.316 equals 20,701. .4. All right, the next type of problems that we'll have to do is solving big division problems that we would have used scientific notation for at one point. We're going to solve them using powers of 10. Here's what I mean. If I do log of each of these numbers without a base, so with base 10, so the common log of all of these numbers, what I can get if I do log of 47,832, I'll get an exponent out. So if I do log 47,832. I would get 4.68. What that means is this number can be rewritten as 10 to the 4.68. That's that number. Then if I did the same thing with 59,463, so log of 59,463, I would get 4.77. So this would be 10 to the 4.77. And then I can put that over and do the same thing here. Log of 0.000817 would be negative 3.09. So this would be 10 to the negative 3.09. Here's why this helps, and it's not exact because we did round the exponents, but now I can just add these exponents and subtract that one. So this would be 10 to the 4.68 plus 4.77, and then minus negative 3.09, so plus 3.09, and I should get 10 to the 12.54, which I then can just type into my calculator. 10 to the 12.54. And I would get 3.46 times 10 to the 12th, or 3.47 actually. 3.47 times 10 to the 12th. And that's just kind of a quick way that I can do it. This next one though is the same exact problem, but it says solve using powers of e. So all that changes is instead of using 10 to a power, which means we did log, we're going to do ln, my natural log of this number. So I'll do ln of 47,832. That'll get me 10.78. So that means I can rewrite this number as e to the 10.78. Then do the same thing, ln of 59,463 equals 10.99. So that's my power, e to the 10.99, and then over ln of 0.000817, and I'll get negative 7.11. Okay, and then same thing as up here, I can do e and add my exponents. So e to the 10.78 plus 10.99 minus negative 7.11 should be, if you add it correctly on your calculator, e to the 28.88. And then you can type that back in to get your final answer. So remember, second ln is how you get e to the 28.88. And you should get 3.449 times 10 to the 12th. And look how similar our two answers are. They're a little bit different because for one we use base 10 and for one we use base e. But that's a way to solve these types of problems using logarithms. The last type of problem we have to learn how to do is problems like this. If negative 0.0325 equals log base e of y, find y. Well, this is the same as we did for base 10, but just with base e. So I can rewrite this as ln actually. So ln of y equals negative 0.0325 because log base e is ln. So let's rewrite this as an exponential because I'm missing my answer. This would be base e to this power, negative 0.0325, equals y. So if I do that on my calculator, I would have second ln, which would get me e, to negative 0.0325, which would get me 0.97. So y equals 0.97. That'll be your answer. And then the last one, if y equals 4,302, find a log of y, b ln of y. So a log of 4,302, b ln of 4,302. These are as easy as just plugging it into your calculator. So again, log 4,302, 3.63. That's A. And then ln, 4,302, 8.37.